Hello and welcome back guys with a brand new video, and in the previous video we discussed about the electronic passive components, and we discussed resistors in details, and in this video we will uh, discuss about the capacitors, and that first we need to define that what is a capacitor. So basically a capacitor is a device that stores electric charge. We will see in this video also that's how a capacitor stores the electric charge. Capacitors basically consist of two conductors, and these two conductors are separated by an insulator, and I will also try to show you that's how the two inductors and an insulators is attached to make a capacitor. So if we look at the types of the capacitors, then we have here two types of capacitors: a parallel plate capacitor and a cylindrical capacitors. The picture you have seen on your first uh, page of the video here is you can check is here a cylindrical capacitor. So a cylindrical capacitor is a parallel plate capacitors that has been rolled with an insulating layer between the plates, and they have many insulating layers, but in case of parallel plate capacitors there is a single insulator is placed between the two conductors. So we also need to know when we are talking about the capacitors, about the capacitance. Here you can see that we have the two conductors. The one is positively charged because it is attached with the positive terminal of the battery, and the other one is negatively charged due to the negative, it is attached with the negative terminal of the battery. And here we have the insulator is air. So if you look at these capacitors, it means that we have one conductor, second conductors, and an insulator air. So in this, as you know already, that a capacitor in simple electric circuits is represented, is stored the charge, and the charge is represented using the Q. And if we discussed about the Q, basically the capacitor is, you can say, is proportional to the difference between V and Q. So if we look at the definitions, then the stored charge, the charge that is stored in the capacitor is proportional to the potential difference. Here V is the potential difference between, you can say, of the voltages of the battery, uh, and it will be the potential difference because the electrons move from positive terminal to the negative terminal, and when electrons move from positive terminal to the negative terminals, then our potential difference will be V equal to the battery voltages. The capacitance C is here a constant of proportionality, and it is measured in farads, and farads is equal coulomb over volt. As I already told you in the start, that it will be the divisions of charge and voltages. So here we have the exercise to calculate, that is very simple exercise. You only need to put the values in the calculators to calculate the capacitance. So I think we do not need to waste on time on this, and so we move on about on the other types of the capacitors, including fixed capacitors and variable capacitors. In case of fixed capacitors, the values of the capacitors is remain fixed, it will not change. But in case of variable capacitors, we can change the value of the capacitors. Here the fixed capacitors includes electrolytic capacitors, mica capacitors, ceramic capacitors, and paper capacitors. We have also comes here some other types of capacitors, that including yeah, using the insulator oil as an oil. And here we have the variable capacitors, gang capacitor, trimmer, padder. So if we talk about the fixed capacitors, as I told you that fixed capacitors whose capacitance value is fixed. So here, if we talk about the first type of the fixed capacitors, the electrolytic capacitors, then you will see here electrolytic capacitor basically a type of capacitor that is polarized, made of aluminum plates and oxide as dielectric. Dielectrics, I hope you understand about the dielectrics. They are able to offer high capacitance values, typically above 1 microfarad, and it provides low frequency applications, power supplies. In its applications is including low power applications, which includes power supplies, decoupling, and audio coupling applications, as they have a frequency limit if around 100 kilohertz. So if we talk about the mica capacitor, you can see here it's not polarized, made of metal plates and mica as dielectrics. Its range up to 5 to 10,000 picofarads, rated up to 500 volt. High frequency is used in high frequency applications, resonance circuits, and high frequency filters. Then we can discuss about the ceramic capacitors. It's not polarized, made of silver, copper plates, and titanium barium as the dielectric, and its range from 3 picofarad to 12 microfarads. High frequency applications is the application of ceramic capacitors. Then we talk about the paper capacitors. Here you can also look at how the paper capacitors looks. It's also not polarized, made of aluminum foils separated by strips of paper soaked in dielectric. And if you open the capacitor, you will look the same paper soaked in dielectric, and its range is from 0.0005 UF to several UF. And its disadvantage is that it's large in size, and its application is also the high voltage applications. Look at this, it's high voltage, it's not high frequency applications. So if we talk about here about the variable capacitors, capacitors whose capacitance value can be varied, and so it's used on very large purpose, uh, and gang capacitors, rotor, stator management with two sets of metal plates. Here you can also check out how it looks like. It's fixed plates, stator movable plates, rotors to change the value of the capacitors. A movable plate connected to the shaft, and capacitance is varied by rotating the shaft. Applications, if we talk about, then it's used in the tuning of radio receivers. And then the other type of the variable capacitor is streamer. Its construction is it's constructed using the metal plates separated by dielectric mica ceramic, and capacitance variation is done by rotating the screw, and its range in picofarad. Its applications used where tuning is not very frequent, tuning of broadcast receivers. And then we discussed about the padder. The padder is constructed using the aluminum plates separated by dielectric air. Here we have using the dielectric as an air. Capacitance variation is done by rotating the screw, and its range is 5 picofarad to 600 picofarad. Then we also need to, when we are discussing about the capacitors, we also need to understand that how, what's the meaning of the numbering on the capacitors. Here you can see if the number is greater than and 1, then it is picofarad, and if the number is less than 1, then it is microfarad. Now here you can check that 104 means the first one is showing that the number is greater than 1. It's, you have to only pick up the first two digits. So it means the number is greater than 1, so the capacitor will be a picofarad capacitors, and these fours will show us the number of zeros attached with this 10. So 10,000 picofarad. Here we have another examples that 10k means the number is greater than 1, so the capacitor will be a picofarad capacitors, and k means 10k picofarad capacitors. And here you can check out here also 4k7 means 4.7 kilo picofarad capacitors, 2.2 mega picofarad capacitors, 47 nanofarad capacitors, 47 point it's now it's and showing is already nano, so it's 47 mega means 47 megafarad capacitors, 104k means 10%, and 104 m means 20% tolerance. It's also showing tolerance. So the our next topic is inductors transformers that we will discuss in our next video. So if you learned anything new, then please subscribe the channels, and if you required any type of assistance in your electrical and electronics projects regarding the tutorings and assignments and projects, then you can ping me a message on my WhatsApp number that is given in the description, and also you can visit my Upwork and Fiverr profile. Thank you so much for watching the video.